Okay, so what we're talking about today is called probability, which I'm sure you guys have heard before. A few important things to know about probability is this stuff up here on the right. Probability is always expressed as a fraction, a decimal, or a percent. It has to be between 0 and 1. So probability of 1 is 100%. So you would never say probability of something is 150%, for example. You all have heard probability before, right? So a lot of times you hear it in terms of like the weather. The probability that it's going to rain today is 30%. Normally they say chance, but they just mean probability. If you have a probability of 0, what does that mean? Not going to happen. Yeah, probability of 0 is definitely not going to happen. What does the probability of 1 mean? For sure going to happen. So if I ask you, what is the probability that you're going to have homework tonight, what would you say? 1, right? It's already written on the board what your homework is, so you know for sure that you're going to have homework. Probability basically comes down to how well you read. That's it. So all you have to do is read the questions carefully. If we look at this example, for the tables 1 through 5, or a table with examples 1 through 5, it says a survey of 100 randomly selected teenagers aged 14 to 17 in the U.S. was conducted to gather data on summer employment of teenagers. The data are shown in the table. Okay, so if we look at this table, everyone was asked 2 questions. How old are you? And their age was recorded. And then, do you have a summer job? And then we noticed there were 170 people that were surveyed. So the first question is, what % of those surveyed had a summer job? Okay, so the way probability works is we're always going to start by expressing it as a fraction. The denominator of the fraction is all the people that are included. So in this case, what is the % of those surveyed? Well, I surveyed 170 people. And then I want to know, what is the % who had a summer job? How many people out of those 170 had a summer job? 59. So it would be 59 out of 170. Now let's make sure we answer the question the way that it is asked. The question says, what is the %? So if you divide this, you get 0.347, which is 34.7%. So then example 2, what is the probability of being 14 or 15 and having a summer job? So again, I'm looking at all 170 people. I want to know, out of those 170 people, how many are 14 or 15 and have a summer job? How many is that? 20. Now, it's always good to express this as a decimal as well. When you do, you get 0.118. So either of those answers would be acceptable. SAT doesn't care. I don't care either. Example 3. If a random individual from the sample is chosen, what is the probability that the individual is 14 or 15 and does not have a summer job, or the individual is 16 to 17 and does have a summer job? So if a random person from the sample is chosen, so I have 170 options of people to choose, what is the probability of being 14 and 15 and not having a summer job? How many people is that? 14 to 15 and does not have a summer job? 69. And then 16 to 17 and does have a summer job? 39. So that's, I think, 108 out of 170. Convert it to a decimal just to make sure it makes sense. You get 0.635. Okay, examples 4 and 5 are where reading carefully comes into play. Okay, so example 4. If a person is chosen at random from those who does not have a summer job, what is the probability that he or she is 16 to 17? I'm no longer looking at all 170 people. I'm now only looking at the people who do not have a summer job. So how many people do not have a summer job? 111. So then out of those 111, how many are 16 to 17? 42. So that ends up being 0.378. So it's really important that you read carefully to understand, am I looking at the whole sample or just a part of it? So example 5, if a person is chosen at random from those who are 14 to 15, what is the probability that the person does not have a summer job? First question to ask yourself, are we looking at everyone? No. We're only looking at people who are 14 to 15. How many of those people are there? 89. Now, out of those 89 people, how many do have a summer job? 20. So that probability ends up being 0.225. Okay, do we have a question or questions? No? Okay, so what you're going to do now is you guys are going to try this one at the top. It's a very similar problem. Make sure that you read carefully. So you're doing problems 6, 7, and 8. Okay, example 6. What is the probability of being an underclassman and having a driver's license? Anyone?
1, 3, 5, 6.
Can you give me the fraction?
89 over 250.
89 over 250. Everyone agree?
Yeah. No.
No? Vladimir, what did you get? Can you give me the fraction?
89 divided by 600.
Okay, Mandy, is that what you got? 89 out of 600? Okay, what is the probability of being an underclassman and having a driver's license? So the question, so we all agree on the 89 part. We don't agree on the denominator, though. So the question is, are we looking at everyone, or are we looking at just a subset? Yeah, there's nowhere that it says, looking at this group of people, or if a person is chosen from this group. So we're looking at everyone. The answer is 89 out of 600. Okay, the time when the denominator changes is in problem 7. For problem 7, if a person is chosen at random who does not have a driver's license. So that's telling us we're not looking at all 600, we're only looking at the people who don't have a driver's license. So that's out of 240. So people who do not have a driver's license. What is the probability that he or she is an upperclassman? So out of those 240 people who don't have a driver's license, 161, nope, 79, sorry. Are upperclassmen. How did we do on that one? That one. If a person, number 8, if a person is chosen at random, are we looking at everyone or just a subset? Everyone, all 600. What is the probability that he or she is an underclassman with a driver's license? So that's 89. Or an upperclassman without a driver's license? That's 79. What do you get when you add those together? 168. Okay, and I believe that simplifies to 7 out of 25, which is 0.28. Okay, how do we feel about that before moving on? Good. Okay, we're going to do a few more examples together, like example 9. Whew. Data was collected on ice cream flavor preference for a group of freshman and sophomore students at PHS. The partial data table is shown at the right. There are 2 times as many freshmen that prefer chocolate as there are freshmen that prefer vanilla. There are an equal number of sophomores who prefer chocolate as vanilla. If a student is chosen at random, what is the probability that the student is a freshman that prefers chocolate? Okay, so we can't answer this question yet because we don't have very much information in the table. So what is the probability that the student is a freshman that prefers chocolate? That's these people right here. Problem being, I don't know those people. So we're going to need to use this information, that middle section. There are 2 times as many freshmen that prefer chocolate as freshmen that prefer vanilla. What can I do with that? 2x. So twice as many freshmen prefer chocolate. The vanilla then is just x. There are equal number of sophomores who prefer chocolate as vanilla. Y and y. Okay, so if a student is chosen at random, what is the probability that the student is a freshman that prefers chocolate? Okay, so for this probability, are we looking at everyone or just a subset? Everyone. We're looking at the whole group. So there's 210 people total. Freshmen that prefer chocolate, there are 2x of those. Now, that's not an answer choice. We need to figure out what x is. So, any ideas as to how to find x? Besides just guessing, because I don't want to do that. Come on. Close. Yeah. Look at all the whole chocolate column. There's 2x freshmen, there's y sophomores who like chocolate, there are 120 students total that like chocolate. Now, can I solve this equation for x or y? And get a number? No, right? 2 variables, I'm going to need 2 equations. That means vanilla also gives me an equation. So I get x plus y equals 90. We've created ourselves a system that we need to solve. Do you remember how to solve systems?
The matrix, yes.
I don't want to use a matrix, although you could.
Dang it.
Ideas?
Multiply the bottom equation by -1.
Multiply the bottom equation by -1. Why? What are we trying to do?
Cancel out the y's.
Yeah. So keep the first equation the way that it is. Bottom equation we multiply by -1. What is this called? Elimination. Now, when we add together, those y's cancel out. We get x equals 30. Now, when we go back into our probability, 2x will be 60. So we get 60 out of 210, which is answer B. Okay, flip the page. Okay, you all have a few more to try, and then we're going to do the last one together. So I want you guys to try these that have to do with movies. So for the first one, what proportion of the movies are comedies with a PG-13 rating? Are we looking at all the movies or only a subset? All the movies. So out of all 50 movies, how many of them are comedies with PG-13? 4 of them. That simplifies to 2 out of 25. Next one. If a PG-13 movie is chosen at random, what is the probability that it is an action movie? Am I looking at all movies or just a subset? Just a subset. I'm only looking at PG-13 movies. There are 22 of those. Out of those 22, how many are action movies? 10. So that simplifies to 5 out of 11, which is 0.45 repeating. So any of those answers would have been acceptable. Last one, what percentage of the movies are action movies? So out of all 50 movies, 18 of them are action movies. Did you change that to a percentage to answer the question? Yeah. Good. So that should have been 36%. Okay, we're going to do one more together, and then we'll be done with notes. Okay, so it's about the job data still. In 2012, the total population of individuals in the U.S. who were between 14 and 17 inclusive was about 17 million. If the survey results are used to estimate information about summer employment of teenagers across the country, which of the following is the best estimate of the total number of individuals between 16 and 17 in the U.S. who had a summer job? Ooh. Any ideas? Yeah, that's exactly what you're supposed to do. We're going to do a proportion. So, first piece of information we are given is 17 million. Okay, it's important for us to know what that is. That is all 14 to 17-year-olds. Out of those 17 million, I want to know how many had a summer job. Okay, so then everything on the right is going to come from our sample, our actual data. In the denominator needs to go how many 14 to 17-year-olds there were. 14 to 17. 170, yeah, it was the whole sample. And then I want to know how many had a summer job. So out of those 170, how many had a summer job? 59. And then you're going to cross multiply or do cross products. I believe you get 3.9. It's important to recognize that that's 3.9 million, which is B. Okay, do we have any questions on probability? Daniel?
It says for total number of individuals between 16 and 17 years old, so would you do 39 instead of 59?
Yes, thank you. Yes, that's really important. Sorry. Okay, yes, between 16 and 17 who had a summer job. So we're not looking at all of them. We're only looking at those 39.
Do you still keep the 170 then?
Yes.
Okay.
Yes, the reason you still have to use 170 is that 17 million is all 14 to 17-year-olds. So those have to match. I believe you still get 3.9 million. It's 3.9, right? Not 0.39?
Yes.
Okay. So the answer is still B then. Thank you for correcting my mistake. Any questions? Okay, I need you guys to give me 30 more seconds to say a few things. First of all, due on Monday is pages 24 to 26. Answer key is not on Schoology. A lot of it is multiple choice, so again, you're not going to get credit unless you show work. Second of all, you have a quiz on Monday that covers all the stuff that we've done in SAT. There is a review on Schoology that is completely optional and has an answer key with all the solutions. I would suggest this weekend that you look at it and do whatever practice you need. I'm not telling you to do the whole thing, but do whatever practice you need. Your quiz, like I said, is Monday. Tuesday, we will start Chapter 8. Sound good?